Okay, you've heard the term machine learning tossed around everywhere, right? It's in the news, it's all over new tech, maybe it's even part of your job. But what in the world does it actually mean? Well, today we're going to break it all down. We're going to demystify that buzzword and really crack the code of machine learning. So, here's our game plan. First, we're going to get a super clear definition of what machine learning, or ML, really is. Then, we'll take a quick look at its history, explore the three main ways machines actually learn things, and finally, we'll see where this incredible technology is popping up in our everyday lives. All right, let's dive right into that first big question. What are we really talking about when we use the words machine learning? You know, this question right here, it gets to the absolute heart of it. For pretty much all of computing history, we had to tell computers exactly what to do, step by step by step. Machine learning completely flips that idea on its head. It asks, hey, what if a computer could just figure out the steps on its own? What if it could learn just by looking at a bunch of examples? And here we have the more formal definition. At its core, machine learning is just a part of the bigger field of AI. And the whole idea is that instead of us writing endless lines of code for every little task, we just feed the computer a whole lot of data and tell it, hey, you figure it out. They learn to spot patterns and make decisions all by themselves. It's pretty wild. This diagram here really simplifies the whole process. So think of it like this. All that stuff on the left, that's the past data. It's like the experience we feed the computer. The algorithm studies all of that and builds its own kind of understanding, its own logic. That's the model. And then when it sees something new, it uses that model to make a prediction. It's kind of like its own little crystal ball. But listen, this whole idea of a learning machine didn't just pop up out of nowhere. As we're about to see, this is a concept that's been cooking for over half a century, slowly but surely moving from a cool theory to the reality that we all live in today. This timeline really puts that long journey into perspective. And you know, the key thing to realize here is that for decades, the progress wasn't held back by a lack of ideas. The ideas were there. The problem was a lack of computing power. The real game changer came pretty recently with the rise of these super powerful graphics processing units, or GPUs. All of a sudden, we had the raw horsepower needed to train these incredibly complex models that are now literally changing our world. So, how exactly do machines learn? Is it just one method? Nope. It's kind of like how people have different learning styles. Well, machines have a few main approaches, or paradigms, too. Let's break down the three big ones. This chart kind of gives us a map of the two most common ways. On one side, you have supervised learning, and on the other, unsupervised learning. They solve very different kinds of problems in, you guessed it, very different ways. Okay, think of it this way. Supervised learning, that's like studying for a test with flashcards that have the answers on the back. The data is all labeled. We tell it, this image is a cat, this one is a dog. The machine learns by example. Now, unsupervised learning is more like a detective showing up to a crime scene with zero clues. It just has a big pile of unlabeled data, and it has to find hidden patterns or groupings all on its own, like figuring out how to group customers based on what they buy. And this visual right here is the perfect example of supervised learning. The algorithm gets shown thousands and thousands of pictures that are already labeled dog or cat. By studying all of those examples, it starts to learn the key features of each. Pointy ears, whiskers, tails. It builds a model. And then, after all that training, you can show it a brand new photo it's never seen before, and it can predict with pretty amazing accuracy which one it is. Now, the third style is reinforcement learning. And this one is all about learning through trial and error. You have an agent, that could be a robot or a character in a video game, and it takes actions in some environment. It gets a reward, like a point for a good action, and a penalty for a bad one. Over millions and millions of tries, it just figures out the strategy that gets it the most rewards. This is exactly how we train AI to master super complex games, or even how we teach self-driving cars to navigate traffic. So that's the theory, but let's bring this back down to earth. Why does any of this really matter to you? Well, the truth is, you are interacting with machine learning systems all day, every single day, whether you realize it or not. I mean, think about it. Every time your streaming service suggests a new movie that you might actually like, that's a recommendation engine powered by ML. That spam filter that keeps your inbox clean? Yep, that's machine learning. When your bank sends you a text about a charge that looks a little weird, that's a fraud detection model at work. From the voice assistant on your phone to huge advances in medical diagnosis, ML is humming along quietly behind the scenes. So when you really boil it all down, machine learning is our best tool for making sense of the absolutely insane amount of data in our world. It's how we find the signal in all the noise. It is the engine that turns all that raw information into sharp predictions, better decisions, and brand new insights that might just help us solve some of our biggest challenges. And that leaves us with this final, kind of provocative thought. As this technology gets more and more powerful, and it's doing so at an incredible speed, the focus really starts to shift. It's not just about if a machine can learn anymore. It's about what we should teach it. What problem should we point it at? What values should we build into these systems? Now, that is the conversation that we all need to be a part of.